Hi, my name is Mosh Hamedani, and I'm going to be your instructor in this React crash course. First, I'm going to give you a quick 3-minute introduction to what React is and why you should learn it, and then we're going to jump in and build a React application together. This application we're going to build throughout this course may appear simple, but actually it exhibits patterns that you see on a shopping cart page. So imagine these are the items on a shopping cart. We can change their quantity, delete them, reset the quantity of all items to 0, and we also have this number on the navigation bar showing the number of unique items in our imaginary shopping cart. So by the end of this crash course, you will have a good and in-depth understanding of React fundamentals. You'll be able to build reusable components, render data, handle events, and debug your React applications. If you enjoyed this tutorial, please like it and share it with others. Are you excited? Now, let's get started. React is a JavaScript library for building fast and interactive user interfaces. It was developed at Facebook in 2011, and currently it's the most popular JavaScript library for building user interfaces. As you can see on Google Trends, React is dominating the space of libraries and frameworks for building user interfaces. The other two players here are Angular and Vue. So if you want to expand your job opportunities as a front-end developer, you should have React on your resume. At the heart of all React applications are components. A component is essentially a piece of the user interface. So when building applications with React, we build a bunch of independent, isolated, and reusable components and then compose them to build complex user interfaces. Every React application has at least one component, which we refer to as the root component. This component represents the entire application and contains other child components. So every React application is essentially a tree of components. If you have worked with Angular 2 or higher, this should sound familiar. Here's an example. Let's imagine we want to build an application like Twitter. We can split this page into components like navbar, profile, trends, and feed. Here's a representation of these components in a tree. So on the top we have app, and below that we have navbar, profile, trends, and feed. Now feed includes several tweet components. Each tweet component can include a like component, which we can reuse on other pages or even in different applications. So as you see, each component is a piece of UI. We can build these components in isolation and then put them together to build complex UIs. In terms of implementation, a component is typically implemented as a JavaScript class that has some state and a render method. The state here is the data that we want to display when the component is rendered. And the render method, as you can tell, is responsible for describing what the UI should look like. The output of this render method is a React element, which is a simple, plain JavaScript object that maps to a DOM element. It's not a real DOM element, it's just a plain JavaScript object that represents that DOM element in memory. So React keeps a lightweight representation of the DOM in memory, which we refer to as the virtual DOM. Unlike the browser or the real DOM, this virtual DOM is cheap to create. When we change the state of a component, we get a new React element. React will then compare this element and its children with the previous one. It figures out what is changed, and then it will update a part of the real DOM to keep it in sync with the virtual DOM. So that means when building applications with React, unlike vanilla JavaScript or jQuery, we no longer have to work with the DOM API in browsers. In other words, we no longer have to write code to query and manipulate the DOM or attach event handlers to DOM elements. We simply change the state of our components and React will automatically update the DOM to match that state. And that's exactly why this library is called React. Because when the state changes, React essentially reacts to the state change and updates the DOM. One of the questions that I often get is React or Angular? Well, both React and Angular are similar in terms of their component-based architecture. However, Angular is a framework or a complete solution, while React is a library. It only takes care of rendering the view and making sure that the view is in sync with the state. That's all React does, nothing less, nothing more. For this very reason, React has a very small API to learn. So when building applications with React, we need to use other libraries for things like routing or calling HTTP services and so on. But this is not necessarily a bad thing because you get to choose the libraries that you prefer as opposed to being fixed with what Angular gives you, which often breaks from one version to another. So that's all about React. Next, we're going to set up our development environment. All right, this is where the fun begins. The first thing I want you to install is Node.js. Now, in this course, we're not going to use Node. We're only going to use one of its built-in tools, Node Package Manager or NPM, to install third-party libraries. So if you don't have Node on your machine, head over to nodejs.org and download and install the latest stable version. Once you do that, open up the terminal on Mac or command prompt on Windows and run this command. npm I, which is short for install, -g, which is short for global. And here's the package we're going to install. create-react-app. We're going to use this package to create a new React app. Now, I want you to install the exact same version I'm going to use in this course because in the future, there might be breaking changes and you might get frustrated if what you see is different from what I'm going to show you. So here, @ version 1.5.2. Now, if you're on Mac and you haven't configured permissions properly, you need to put sudo in the front of this command. So, sudo. With this, we'll run this command under administrative privileges. Let's enter the password. Okay, beautiful. Now, the next thing you need is a code editor. The code editor I'm going to use in this course is Visual Studio Code or VS Code. Chances are you use the same because it's a beautiful, lightweight, and cross-platform editor. If you don't have it, you can download it from code.visualstudio.com. So here's VS Code. We're going to install two extensions that make it easier to build React applications in VS Code. So open up the extensions panel on the left and search for simple React snippets. Here's the extension I'm talking about. It's developed by Berk Holland, and currently there are more than 40,000 downloads. Very, very popular extension. So install it, and then you will have to reload VS Code. The other extension we're going to install is Prettier. So search for Prettier Code Formatter. This one is developed by Espen Petersen, and currently there are more than 2.7 million downloads. We use this extension to reformat our code. Now, one thing I highly encourage you to do so is to enable formatting on save. So whenever you save the changes, this extension will automatically reformat your code. To do that, you need to go to the settings page. Now here I'm on Mac. I'm not entirely sure how to do this on Windows, but that should be pretty straightforward. So here on Mac, we go to the code menu on the top, then preferences, and finally settings. So here on the right side, under user settings, I want you to add this setting. Editor.format unsave, set this to true. And finally, let me show you what theme I'm using here, because that's a question I get quite a lot. So on the top, go to the code menu, preferences, color theme. This is the theme I'm using. So IU or AU Mirage. So I leave it up to you to download and install this if you want to. Next, we're going to create our first React app. Now let's use the create React app package to create a new React application. So here in the terminal, let's run create React app and give our new application a name. Let's call it React app. Now this is going to install React as well as all the third-party libraries we need. So it's going to install a lightweight development server, Webpack for bundling our files, Babel or Babel for compiling our JavaScript code, as well as a bunch of other tools. So when you create an application using Create React App, you don't have to do any configuration. All the configuration is done for you. However, if you want to customize this configuration for your production environment, you can always eject by running npm run eject. We'll look at this later in the future. So now we have a fully working React app. Let's go to this new folder, React app, and run npm start. So this will launch our development server on port 3000 and open up Chrome or our default browser pointing to localhost port 3000. Now let's go back to VS Code and see what we have in this folder. So here we have 3 folders: Node modules, which is where we have all the third-party libraries as well as React itself. We never have to touch this, so let's not worry about it. We've got this public folder where we have the public assets of our application, such as a favorite icon and index.html. Now, if you look at this file, this is a very simple template. It doesn't really have anything. So a bunch of meta tags in the head section, as well as links to our manifest.json file and favorite icon. Manifest.json includes a bunch of metadata attributes about our application. Again, we don't have to worry about this, but if you look further below, here in the body section, you can see a single div with the ID root. This is where our React application is going to appear. So this div is the container for our React application, as you will see shortly. Now back to our files panel. We've got this source folder where we have a basic component that is app component. And that component is responsible for rendering this black banner on the top. So the output of that component is what you see here. Let's have a quick look at app.js. So you can see here we are using ES6 classes. We have a class called app that extends component, which is one of the built-in classes in React. Now, as you can tell, as a React developer, you need to understand what classes are and how to use them. If you're not familiar with these classes, I have a comprehensive course called Object-Oriented Programming in JavaScript. There, I cover classes in full detail. But to help you get started quickly, in the next section, I'm going to give you a quick overview of all the modern JavaScript features that you're going to use frequently in React applications. So if you're not familiar with classes or modules, don't worry for now. We're going to get to them shortly. Now look at this class. Here we have a render method or a render function where we return a markup like this. Now, this is something you probably haven't seen before because we cannot have markup like this in JavaScript. Note that this is neither a string nor HTML. This is what we call JSX, which stands for JavaScript XML. So we use this syntax, which looks very familiar to us, to describe what the UI is going to look like. So this markup represents this black banner on the top. This is the output of our app component. Now, to make this code work, we have to pass this code through Babel, which is a modern JavaScript compiler. So Babel will take this JSX syntax and convert it to plain JavaScript code that browsers can understand. Let me give you a quick demo. Head over to babelJS.io/REPL or REPL. Here we can type modern JavaScript code, and Babel will convert that code into code that browsers can understand. So here I'm going to define a constant, which is a new ES6 feature, call it element, and set it to a JSX expression. So H1, let's say hello world, and we close it here. Again, note that here we are not setting element to a string. This is JSX, so we don't have quotes here, right? Now on the right side, look, this code is converted to a call to react.createElement. The first argument to this method is H1, which determines the type of our element. And the third argument is the text that we want to put in between these H1 tags. So as you can see, using JSX to describe what the UI looks like is much easier than writing plain React code like this. So in our components, we'll always use JSX, and we'll leave it up to Babel to compile that JSX code into calls to react.createElement. Now back to our files panel. Here we have app.css, which includes all the CSS for our app component. You can see this CSS file is imported into our component here. We also have a test file that is app.test.js. In this course, we're not going to look at testing. That's a topic for my advanced React course. We also have index.js, which is the entry point for our application. Don't worry about the code here. We're going to write it from scratch in the next lecture. Similarly, we have index.css. We also have logo.svg, which is the logo of our application. And finally, register service worker.js. This is some code that is automatically generated by Create React App, and it may change or disappear in the future. But at the time of recording this, basically what this file does is it serves assets from a local cache in a production environment. So for now, we don't have to worry about this. Next, I'm going to show you how to write some React code from scratch. All right, now I want you to delete all the files inside of the source folder. You're going to write everything from scratch. So let's start by adding a new file here. Call it index.js. Here we need to import a couple of objects from React modules. So if you're not familiar with ES6 modules, don't worry, just code along with me. We'll get to them in the next section. So import React from React. So this is the module, and this is the object that we're importing from that module. The other object we need to import is React DOM, and we're going to import this from react-dom. Now let's define an element. So const element. Const is a new feature in modern JavaScript. Previously we used only var, but now we have const and let. Again, in the next section, I'm going to give you a quick overview of all these new features. So let's define a constant element and set it to a JSX expression. So h1, hello world, and close h1. Now, as I told you before, Babel will compile this down to a call to react.createElement. And this is the reason why we have to import React on the top, even though we're not going to directly use this object in our code. But when our code is compiled, because there is a reference to React, that's why we have to import it on the top. Now, let's log this element on the console. So here's one thing you need to know about projects that are created with Create React App. Whenever you save the changes, this application is automatically restarted. So you don't have to go back in the browser and refresh it. This is what we call hot module reloading. So save the changes. Now back in the browser, you can see I didn't refresh the page, and that black banner that we had on the top is now gone. Now open up the console. You can do that using Alt, Command, and I on Mac, or Alt, Control, I on Windows. If that shortcut doesn't work for you, go to the View menu on the top, Developer, and Developer Tools. So here on the Console tab, you can see we have an object. This is the output of a JSX expression. This is a React element. So you can see the type of this element, the type property is set to h1, and we have a bunch of other properties here. So earlier at the beginning of the course, I talked about virtual DOM, which is a lightweight in-memory representation of the UI. It's not the real browser DOM, it's the virtual DOM. And this object you see here, this React element, is part of that virtual DOM. So whenever the state of this object changes, React will get a new React element. Then React will compare this element with the previous one. It will figure out what is changed, and then it will reach out to the real DOM and update it accordingly. Okay, so here we have a JSX expression. The result of that is a React element, which is part of the virtual DOM. Now we want to render this inside of the real DOM. And that's why we have to import React DOM on the top. So here we call React DOM dot render. As the first argument, we pass the element we want to render. So here's our element object. As a second argument, we need to specify where in the real DOM we want to render this. So temporarily, let's go back to the public folder. Here in index.html, earlier I talked about this div with the ID root. I told you that this is the container for our React application. So back to index.js, we need to use plain vanilla JavaScript to get a reference to that DOM element. So we call document.getElement by ID. And here we pass the ID that is root. So this React DOM will get a reference to this and render this React element inside of that element. Save the changes. Back in the browser, you can see our hello world message. Let's right click this and inspect it in Chrome Developer Tools. Here we can see our div with the ID root, and inside of this div we have our React element h1 with the tags hello world. Now this is a very simple application. In a real world application, instead of rendering a simple element in the DOM, we'll render our app component. This app component is the root component for our application. It includes children like navigation bar, sidebar, profile, and whatnot. So we'll have a tree of components which will eventually produce a complex markup. Hi guys, thank you for watching my React tutorial. Over the next section, we're going to explore React components in detail. And in that section, we're going to use some modern JavaScript features. If you're not strong in JavaScript and find that section confusing, I highly recommend you to watch my JavaScript tutorial for React developers. You can find the link on the top right corner of the screen here. Also, I wanted to let you know that this React tutorial is part of my complete 10-hour React course. In that course, we'll build and deploy a real video rental application with React from scratch. So by the end of watching the course, you'll be able to build React applications on your own. And you will also receive a certificate of completion. In case you're interested to enroll, you can find the link in the video description below. All right, now let's continue to the next section. All right, we're ready to start learning React. So over the next two sections, we're going to build this application. At the first glance, you may think this is stupid, but this is actually the pattern behind items in a shopping cart. So imagine each row we have here represents a product. Here we have the quantity of that product in the shopping cart. We also have buttons to change that quantity. Note that if the quantity reaches 0, this decrement button becomes disabled. Also, we are displaying the quantity in a yellow badge. So you will learn how to render content dynamically, how to apply CSS classes dynamically. We also have this delete button for removing an item from this list. We also have another button for resetting the quantity of all the items to 0. And finally, we have this badge on the navigation bar, which is like e-commerce applications. So as you add items in the shopping cart, it shows the total number of items in the shopping cart. But in this application, it behaves a little bit differently. It only shows the number of counters with value greater than 0. So currently we have 3 counters, but only the first one, its value is 1. And that's why we have 1 in the navigation bar. If I increment the value of the second counter, now we have 2 in the navigation bar. So this simple application exhibits patterns that you see in a lot of real-world applications. Now, let's get started. All right, let's start by creating a new project. So here in the terminal or command prompt, let's run create React app and give our application a name, counter-app. Okay, beautiful. Our new project is ready. So let's go to this folder, counter app, and start the application. Okay, beautiful. Now, here in VS Code, the first thing we need to do is install Bootstrap. In case you're not familiar with Bootstrap, it's basically a CSS library that gives our applications a modern look and feel. Now, to install Bootstrap, we need to go back in Terminal. But if you look here in VS Code, we have this shortcut, toggle terminal. On Mac, the shortcut is Control and backtick. So let's open that up here. So here we have an integrated terminal. We can run npm install Bootstrap. Make sure to install the same version I'm going to install in this video. So version 4.1.1. Okay, beautiful. Now finally, we need to import this in index.js. So let's open up index.js. Here on the top, we need to add another import statement. So import quotes. Here in the IntelliSense, you can see Bootstrap. So let's go to this folder and then dist, which is short for distributable, then CSS, and finally bootstrap.css. So this is how we import Bootstrap CSS in our application. Save the changes. Back in the browser, you can see the font is changed. Next, we're going to create our first component. All right, now let's create our first component. So here in the source folder, let's add a new folder, components. By convention, we put all our components here. Now in the components folder, let's add a new file. We call it counter.jsx. Note that here I'm using camel notation. So the first letter of the first word should be lowercase, and the first letter of every word after should be uppercase. So if you wanted to call this file counter component, we would name it like this: counter component with a capital C. Okay. Also, I highly encourage you to use the JSX extension instead of just JS, because with this you will get better code completion. So here's our counter module. In this module on the top, we need to import React and the component class from the React module. We can manually type it by hand, but let me show you a shortcut to generate this line. Earlier at the beginning of the course, I told you to install an extension called Simple React Snippet. So here on the extensions tab under installed, you can see I've got Simple React Snippets. This is a very powerful extension. It has a lot of shortcuts to quickly generate code. You can find all the shortcuts below. In this video, I'm going to use a couple of these shortcuts. One is IMRC for generating the import statement, and the other is CC for generating a class component. So back in counter.jsx, type IMRC, which is short for import React component, and press tab. Done. Next, type CC, which is short for create class, tab, done. And here we have multiple cursors. So what we type is reflected in both places. Let's give this component a name. So counter with a capital C. Now to stop multi-cursor editing, press the escape button. So we have this counter class that extends the component class that we imported on the top from the React module. This component class has a bunch of methods that we're going to inherit in this counter class. Okay. Now, this code also generates the state property. In this video, we don't care about this. We're going to look at that later in this section. So delete it and modify the render method to return a simple h1 with the text hello world. Now, to refresh your memory, what we have here is a JSX expression. It's not a string, it's a JSX expression, which eventually gets compiled to calls to react.createElement. That's why we have to import the React object on the top, even though we are not going to directly use this in our code. Okay, so let's delete this line. So we have a simple component that when rendered returns an h1 element, right? Now note that in this generated code, we're defining the class here and then exporting it separately on line 9. This is different from what I showed you in the last section where I talked about modules. There, we defined a class and exported it on the same line. So here we can do something like this. Export default class counter. And then we can delete what we have on line 9. But going forward, I prefer to stick to the template that is generated by this extension, so I don't have to modify it every time. Okay, so let's revert this back. We're done with this component. Now let's use it. So save the changes. We need to go to index.js. So on the top, we can type index.js. And if you're curious how I brought up this little panel, you can find the shortcut here under the Go menu. So on Mac, it's Command and P. On Windows, I'm not sure. You need to find it yourself. So let's go to index.js. Here we need to import our counter class. So import counter from /components/counter. And note that because counter is a default export, we don't need curly braces around it. Okay. Now finally, on line 9, where we are rendering a React component, instead of the app component, we're going to render our counter component. So you can see with these components, we are extending the HTML vocabulary. So wherever we have a counter element, we'll get the output of the counter component, which is determined by what is returned from the render method. Now, back in the browser, you can see our counter component rendered in the DOM properly. All right, now let's add a button here. So right after H1, I'm going to add a button. We set the inner text to increment. Now you can immediately see a compilation error here. You have a red underline. JSX expressions must have one parent element. Why is that? Well, earlier I told you that these JSX expressions get compiled to a call to react.create element. Now, the first argument to this method is the type of the element that we want to create, in this case, H1. But when we have two elements side by side, Babel doesn't know how to compile this long expression into a call to react.create element. What is the type of the React element that should be returned from the render method? We can't tell. So one solution is to wrap this with a div. So let's add a div here and close it at the end. Now, when Babel sees this, it will compile this expression down to something like this. So we'll have a React element with the type div, and inside of that element, we'll have two other elements, an H1 and a button. Okay, so delete. Now see what happens when I save the changes. The prettier extension that I told you to install at the beginning of the course automatically reformatted this expression. Now it's more readable, and it also put parentheses around that. This is essential because of something that we call automatic semicolon insertion. So in JavaScript, if you have a return statement and nothing in front of it, JavaScript will automatically put a semicolon here. So if you add a div on the next line, JavaScript is not going to see that. It thinks you have a return statement with nothing in front of it. To solve this problem, we should put a parenthesis right in front of the return keyword and then close it at the end of our JSX expression. Okay, so delete. Now the good thing is that whenever you're dealing with a long JSX expression, as soon as you save the file, this prettier extension would automatically put these parentheses for you, so you don't have to do it manually. All right, save the changes. Now back in the browser, here's our button. Let's inspect this. So here we have this div with the ID root. This is coming from our index.html. I showed you this at the beginning of the course. So this is the div or the container for our React application. Inside of this div, we have this other div, which we added a minute ago, to wrap our H1 and button elements. Okay. Now, sometimes you don't want an extra div that is not doing anything here. In that case, you can use react.fragment. Let me show you. So back in the code, we imported this React object on the top. This React has a child called fragment. So we can replace these two divs with react.fragment. Now, if you're curious how I edited both these instances at the same time, this is called multi-cursor editing. So we can select a piece of code, press Command and D on Mac or Control D on Windows to find another occurrence of that selection. Now, if you have more occurrences, you keep pressing Command and D or Control D. Now we have multiple cursors. We can change all instances in one go. So react.fragment. Now save the changes back in the browser. This time inside of our root div, we only have the h1 and the button. They are not contained by another div. All right, now let's take this to the next level. Instead of hard coding this hello world here, I want to display a value dynamically. So here in the counter class, we need to add a property, call it state, and set it to an object. State is a special property in React components, and basically it's an object that includes any data that this component needs. So in this case, let's add a property in this object, call it count, and set it to 0. Now here we could have a complex object. For example, we could have an address that could have a street property like this. So basically this state object includes any data that this component needs. In this example, all we need is a count property. So let's simplify this. Now I'm going to replace h1 with a span. So I've selected h1 and I'm pressing Command and D. Now we have multiple cursors. Let's change both instances to span. Done. Now let's remove hello world. Here we want to render something dynamically. To do that, we add curly braces. And in between these curly braces, we can add any valid JavaScript expressions. So if you want to render the value of the count property here, we would write code like this. This, to reference the current object, .state, .count. Now save the changes. You can see the result here. So this is our count. If I change this to 1, save the changes, now we see 1 here. Beautiful. Now, as I told you, in between these curly braces, we can write any valid JavaScript expressions. An expression is something that produces a value. For example, we can write something like 2 plus 2, save the changes, we get 4 here. Or we can call a function that returns a value. For example, let's add a method in this class, call it format count. In this method, we want to check the value of the count property. If it's 0, we want to return 0 as a string. Otherwise, we want to return the value of the count property itself. So we can do something like this. Return this.state.count. If it equals 0, we're going to return the label 0. Otherwise, this.state.count. Now, before looking at the result, I want to quickly improve this code. Look, we have this repetition of this.state.count. Whenever you have code like this, that's a perfect opportunity to use object destructuring that you learned about in the last section. So we can destructure this object and pick the count property like this. Const, we add curly braces, count, we set it to this.state. So we're picking the count property of this object and storing it in a separate constant called count. Now, I'm going to select this expression, press Command and D. So both these expressions are selected. Now let's change both of them to count. That is better. Save the changes. And finally, back here, let's call this.format count. Now save the changes. So currently our count is 1. That's why we see 1 here. Let's change this to 0. Save the changes. We get the label 0. Now to take this to the next level, we can also return a JSX expression here. Because as I told you before, JSX expressions get compiled to React elements. So here, instead of returning a plain text, we can return h1 with 0 as the inner text. So save the changes. Now we have an h1 here. So this is what I want you to understand. JSX expressions are just like normal JavaScript objects. You can return them from a function, you can pass them to a function, you can also use them as the value of a constant or a variable. So here I can define a constant and set it to a JSX expression. That's perfectly fine. So now let's simplify this code. We don't need this anymore. And here on line 19, I just want to return 0 as a plain text. Next, we're going to look at setting attributes. In this lecture, you're going to learn how to set attributes on these elements. For example, let's add an image here. We want to set the source attribute. If we have quotes here, whatever we type in between the quotes is rendered as plain static text. In this demo, we want to set the value of the source attribute dynamically. So let's add a property in this state object, call it image URL, and set it to something like this: https picsum photos/200. This will generate a random 200 by 200 pixel image. Now, back to our image element, let's replace the quotes with braces. In the last lecture, you learned that we can use these braces to render values dynamically. So here we want to render this.state.image URL. Save the changes. This is what we get. Beautiful. Now back to our code. So setting attributes is pretty straightforward, but let's look at setting the class and style attributes because they're a little bit different. So I'm going to delete this image element as well as the image URL. Let's say we want to apply a class to this span element. The name of the attribute is not class, it's class name. Because as I told you before, these JSX expressions get compiled to React elements, which are essentially plain JavaScript objects. We cannot use a class property on an object because that's a reserved keyword in JavaScript. So the name of the attribute in JSX is class name. Here I'm going to use a couple of bootstrap classes. One is badge and the other is badge-primary. Save the changes. This is what we get, a blue badge. Now this badge, this span is pretty close to this button. We can add a bit of margin to let the UI breathe. So back in the code, the name of the class is m-2, so margin 2. Save the changes. Now you can see there's a bit of space in between the span and the button. That looks better. Now similarly, let's apply a class to this button. So back in the code, here's our button, class name. We set this to btn, btn-secondary, and btn-sm, which is short for small. Now, if these classes are unfamiliar to you, you need to look at Bootstrap documentation. That's an entirely different topic. We cannot talk about it in my React course. So save the changes. And now our button looks different. That's much better. Now, finally, let's look at applying styles. So for the most part, it's best to use classes. This is for performance and maintainability. But there are times that you may want to break the rules if you know what you're doing, and you may want to apply a style to a specific element. Now, in JSX, we have this style attribute that we need to set to a plain JavaScript object. So first we need to add curly braces here. Now, in between these curly braces, we need to pass a plain JavaScript object. Here's one way to do this. We can define a property, call it styles, set it to an object. The properties of this object are CSS properties in camel case notation. For example, font weight. So the first letter of the first word is lowercase, but the first letter of every word after is uppercase. Now we can set this to a numerical value like 10, and React will automatically convert this to something like this. So it will append pixels to the end. Actually, this should be font size, not font weight. So font size, 10 pixels, or just a numerical 10. And we can also set font weight to bold. Now we can pass this object here. So this dot styles. Save the changes. Now you can see our text is a little bit smaller and bold. To demonstrate that this is actually working, let me change this to, let's say, 50. Save the changes, and now we have a big badge here. So this is one way to apply styles. We define a property here and then reference it in our JSX expression. But maybe you want to apply styles to a couple of different elements, so you don't want to define multiple properties in this class. If that's the case, you can use inline styles. So here, in between these curly braces, we can just pass an object and set the properties on that object. So let's say font size 30. Now we don't need this styles property anymore. Let's save the changes. With this syntax, we'll get double curly braces. Now back in the browser, you can see our badge, its font size is now 30. In this section, we're only going to use the classes, so I'm going to delete the style attribute. Done. Next, we're going to look at rendering classes dynamically. Our badge is currently blue, but let's change this application such that if the value of the count property is 0, we want to render this as yellow to indicate some kind of warning. Otherwise, we want to render it as blue. So back in the code, when we use the badge primary class here, we get a blue badge. If we use badge warning, we'll get a yellow badge. So in this lecture, we want to render one of these classes dynamically depending on the value of the count property. And this is a pattern that you see a lot in real-world applications. So here's one way to do this. We can define a constant here, call it classes, set it to the string. In this string, we're going to include all the classes that we're going to pass here. So we start with the primary classes that we want to have in all cases, that is badge and M2. So badge and M2. Now, depending on the value of the count property, we want to add badge warning or badge primary to this string. So classes plus equal. Now note that we're modifying this, so we cannot use a constant. That's when we use the let keyword. So if this.state.count equals 0, we're going to append badge-warning. Otherwise, we're going to append badge-primary. Now we could make this a little bit cleaner, so we don't want to repeat badge dash in a couple of places. We can add that here, badge dash, and here on line 10, simply append warning or primary. And finally, replace these hard-coded classes with what we have in this variable. So save the changes. Initially, our count is 0. That's why we have a yellow badge. But if we go back here and change the value of count to 1, save the changes, now we get a blue badge. Awesome. But we're not done yet. Look at our render method. These two first lines are purely about determining the class for this label. They are polluting our render method. It would be nicer if we encapsulated these two lines in a separate method so the details of calculation of the classes is not causing this method to get bloated. So let's extract these two lines in a separate method. Now let me show you a quick tip. I'm going to select these two lines, right click, look at this refactor menu. Note the shortcut. On Mac, it's Control, Shift, and R. So I'm going to use this shortcut, and this brings up the refactoring menu. So here we have a refactoring command called extract to method in class. So let's go ahead with that. Now you can see VS Code automatically extracted these two lines into a separate method. Now we need to give this method a name. Let's call that getBadgeClasses. Always use descriptive names that determine the intention of your code. This makes it easier for other developers to read and understand your code. Okay, so here's our new method. Now we can simplify this code. We don't need this separate variable here. We can call this method directly right here. So this .getBadgeClasses, and then we delete this variable. Now we can see our render method is cleaner. It's not bloated with various responsibilities. Save the changes to make sure everything is working. Our badge is blue, beautiful. Finally, let's change this to 0. Save the changes, and now it's yellow. Perfect. Next, we're going to look at rendering lists. In this lecture, you're going to learn how to render a list of items. So let's imagine we want to render a list of tags here. We start by adding a new property to our state object. Tags, we set it to an array of 3 strings, tag 1, tag 2, and tag 3. Now, here in our render method, we want to render these tags using UL and LI elements. Now, if you have worked with Angular, you have seen the ng4 directive. We use that to implement a loop in our templates. But in React, in JSX expressions, we don't have the concept of loops. Because JSX is really not a templating engine, it's just a simple syntax that will eventually get compiled to React elements. So how can we render a bunch of list items here? Well, in the last section, I talked about the map method of arrays. We can use the map method to map each element in this array into a React element. And with this, we can render a list of items. Let me show you. So here, we want to render something dynamically, so we start with curly braces. Next, we get this .state.tags. This is an array, so here we have a map method. Now, as the argument, we need to pass an arrow function. Tag goes to. Now we get each tag and map it to a list item. As simple as that. So basically what we're doing is we're getting a string and mapping it to a JSX expression, which gets compiled to a React element, which is essentially a plain JavaScript object. So even though the syntax here looks a little bit funny, what we're doing is taking a string and mapping it to a plain JavaScript object, right? Now, here in this JSX expression, we want to render the tag dynamically. So once again, we add curly braces and render the tag. As simple as that. So this is how we render a list of items in React. Let's save the changes back in the browser. So here are our tags, beautiful. However, if you look at the browser console, you should see this error. Each child in an array or iterator should have a unique key. The reason React is yelling at us here is because it needs to uniquely identify each item in this list. Because if the state of this React element in the virtual DOM changes, React needs to quickly figure out what element is changed and where in the DOM it should make changes to keep the DOM in sync with the virtual DOM. So, back in the code, whenever you're using the map method to render a list of items, here, for each item, you need to set the key attribute. So key, we set this to a dynamic value. Here, each tag is a string, and that string is unique. So we can use the same value for the key attribute. Now, in a real application, your tags might be objects, so they could have an ID property. Then you would use that here. Now, just note that this key should only be unique in this list. That is the list of tags. It doesn't have to be unique in the entire application or on the entire page. You could have multiple lists, and each item in a given list should have a key that is unique only in that list. Okay? Now, save the changes. Back in the browser, you can see the warning is gone. In this lecture, you're going to learn about conditional rendering. Now, to help us focus only on a single thing, I'm going to temporarily clean up this code. So in the render method, we don't need the span and the button. Let's delete those. Also, we don't need these two helper methods in the class either. So let's focus on something really simple. So we have an array of items, and we're rendering that in a list. Now here's the new requirement. If this array has at least one element, we want to render that array in a list. Otherwise, we want to display a message like there are no tags. How can we implement this? Well, once again, in JSX, unlike Angular, we don't have if and else because JSX is not a templating engine. So to render elements conditionally, we need to go back to our plain old JavaScript. Here's one way to implement this scenario. We can add a separate helper method like render tags. In this method, we can have our if and else statements. So if this.state, .tags, .length equals 0, we're going to return some text like there are no tags. And of course, instead of returning just plain text here, we could return maybe a paragraph. We're returning a JSX expression, which is a React element. So there are no tags. Or if you don't want to display anything, you simply return null. Okay? So this is the case for an empty array. Otherwise, we want to render the array using UL and LI elements. So I'm going to cut this code from here and simply return it in our method. Finally, in our render method, we add curly braces and call this .render tags. So depending on our state, this method will return either a paragraph or an unordered list with a bunch of list items. Pretty straightforward, right? Save the changes. Back in the browser, currently we have 3 tags, so we see them here. Now, back in the code, if I empty this array and save the changes, we get this message. There are no tags. There is also another technique for conditionally rendering content. Let me show you. So back in the code, here in our render method, just before rendering the tags, let's imagine we want to render a separate message based on a given condition. So we have only a single if statement without an else part, okay? So we can add our curly braces here, write the condition, let's say this.state.tags.length equals 0. If that's the case, we want to render an additional message. We add our logical AND operator here, and then whatever we want to render, we add that here. Let's say, please create a new tag. Save the changes, back in the browser. So here's our message, please create a new tag. This is rendered only if our array is empty. Now, let's investigate how this expression works under the hood. So here we're applying the logical AND operator between 2 values. The first value is the result of this expression, which is a Boolean. It's either true or false. And the second value is a string. In JavaScript, unlike other programming languages, you can apply the logical AND between non-Boolean values. So let's go back to the browser and open up the console. Here in the console, I'm going to write plain JavaScript code. If we type true and false, we get false. What if we type true and a string, like hi? What do you think we're going to get? We get hi. Here's the reason. When a JavaScript engine tries to evaluate this expression, it looks at the first operand. In this case, the first operand is true, so it will look at the second operand. The second operand is not a Boolean true or false, so the JavaScript engine tries to convert this into what we call truthy or falsy. An empty string is considered falsy. A string that has at least one character is truthy. So in this case, hi is considered truthy. So essentially we have two operands that are both truthy. In that case, our JavaScript engine will return the second operand. Let's take a look at another example. So true and hi and a number. Once again, the first operand is truthy, so the evaluation of this expression will continue. The second operand is also truthy, so the evaluation continues. Now we get to the third operand. In JavaScript, number 0 is considered falsy. Any numbers but 0 is considered truthy. So once again here we have 3 truthy operands, and the result of this expression will be the last operand. So we get 1. So back to our render method. To conditionally render content, we can use the logical AND operator. First, we add our condition, then AND, and then whatever we want to render after comes here. It can be plain text or another JSX expression. Now let's see how you can handle events. So all these React elements have properties that are based on standard DOM events. For example, here in our button, we have a property on click. You also have on double click. If you're working with input fields, you have on key down, on key press, on key up, all those standard DOM events that you're familiar with. So here let's handle the on click event. We set this to curly braces because we need to pass an expression. Now, the way we do this is by defining a method here, and the naming convention we use for that is handle. What are we handling here? Increment. So handle increment. Let's do a console.log increment clicked. And then finally, we need to pass a reference to this method here in between curly braces. So this dot handle increment. Note that we are not calling this method, we're simply passing a reference to it. This is different from handling events in vanilla JavaScript. In vanilla JavaScript, we call the target function when setting the onClick attribute. Also note that the name of the event here is case sensitive. So if we use a lowercase c here, we're going to get an error because React elements don't have a property called onClick with this naming convention. Okay, so let's revert this back, save the changes. As you can see, the Prettier plugin automatically reformatted this code. So now each attribute or property is on a separate line. Now back in the browser, let's click this button. There you go. We get these messages here. Beautiful. Now here in this method, we need to increment the value of the count property. But currently there is a problem with our implementation. So if we log this.state.count, we're going to get an error. Let me show you. So here, let's log this.state.count. Save the changes. Back in the browser, click. There you go. Cannot read property state of undefined. So back in the code, this is undefined in this method. Let's verify that. So let's just log this on the console. One more time, let's click this. You can see this is undefined. So currently we don't have access to the state property. Why? That's the topic for the next lecture. So in the last lecture, you learned that in this event handler, we don't have access to this. Why is that? Well, earlier in the last section, you learned that this in JavaScript behaves differently from other languages. So depending on how a function is called, this can reference different objects. If a function is called as part of a method in an object, this in that function would always return a reference to that object. However, if that function is called as a standalone function without an object reference, this by default returns a reference to the window object, but if the strict mode is enabled, this will return undefined. And that's the reason in this event handler, we don't have access to this. So what is the solution? Again, in the last section, I talked about the bind method. We use that method to solve this problem. Let me show you. So here in this class, we're going to add a constructor. This is a method that is called when an object of this type is created. So in the constructor at this point, we do have access to this. So let me show you. Here I'm going to do a console.log saying here we are in the constructor. Let's see what is the value of this. Save the changes. Back in the browser, we get this error that you have seen before. This is not allowed before super. So because we added a constructor in this child class, first we have to call the constructor of the parent class using the super keyword. So we call super, save the changes, back in the console. Now you can see in the constructor, we do have access to our counter object. So this is not undefined at this point. So this is a perfect opportunity to use the bind method. So let's remove this line and type this, that handle increment. So earlier you learned that functions in JavaScript are objects. So they have properties and methods. One of them is the bind method. And with this method, we can set the value of this. So I'm going to use this here. And this bind method will return a new instance of the handle increment function. And in that function, this is always referencing the current object. So no matter how that function is called, this is not going to change. It's always referencing the current counter object. So this method returns a new function. We can get that function and reset handle increment like this. So this, that handle increment, we set that to the function that is returned from the bind method. Okay, so save the changes. Now back in the console, when we click the increment button, we no longer see undefined here. So we have access to the current counter object. And with this, we'll be able to update the state property. So here's one solution to bind event handlers to this. But you might find this a little bit noisy because in every component, you have to add a constructor. You have to call the base constructor. And for every event handler, you have to write code like this. There is another way to solve this problem. This is currently experimental and it may break in the future. So let's see how that works. Instead of adding this constructor, we can convert this function into an arrow function. Once again, in the last section, I told you that arrow functions don't rebind the this keyword. They inherit it. So we can set this to an arrow function and this will solve our problem. Save the changes, back to the browser. Let's call this button. We get our counter object, perfect. So you can see using an arrow function is cleaner and simpler than adding a custom constructor and rebinding every event handler manually. So going forward, I'm going to use this syntax, but if this feature is not available at the time of you watching this video, use the former approach to bind event handlers. Now that we have access to the current object in our event handler, it's time to update the value of the count property. So in React, we do not modify the state directly. In other words, we don't write code like this.state.count+++. It's not going to work. Let me show you. Save the changes, back in the browser, click this button, see, nothing is happening. Well, technically, the value of the count property is being incremented, but React is not aware of that. That's why it's not updating the view. To solve this problem, we need to use one of the methods that we inherit from the base component in React. So we call this .setState. This method tells React that we're updating the state. Then it will figure out what part of the state is changed. And based on that, it will bring the DOM in sync with the virtual DOM. This is different from frameworks like Angular. In Angular, we don't have to do this. Angular automatically detects the changes because in Angular, all browser events are monkey patched. So whenever you click a button or type something in an input field, Angular is notified. It runs its change detection algorithm. It figures out what is changed and it will update the view. React doesn't work that way. We have to explicitly tell React what is changed. So here as the argument to setState method, we pass an object and the properties of this object will be merged with what we have in the state object, or it will override those properties if they already exist. So here I'm going to pass the count property and I want to set its value to this.state.count plus 1. So we get the current count, increment it, and then set it. Now let's delete what we have on line 9, save the changes back in the browser. Let's click this button. You can see our count is incremented because React is aware of the state changes. Now that you have seen a complete example of a component, let's see what exactly happens under the hood when we click the increment button. At this point, we're calling this.setState. This method is telling React that the state of this component is going to change. React will then schedule a call to the render method. So sometime in the future, this method is going to be called. We don't know when. This is an asynchronous call, which means it's going to happen in the future. It may happen 5 milliseconds later or 10 milliseconds later. We don't know. So at some point in the future, the render method is going to be called. This method, as you can see, will return a new React element. That element is this div that we have on the top. This React element has two children, a span and a button. So our virtual DOM is a tree of 3 elements. A React element on the top, that is our div, with 2 children. Okay? So here's the new virtual DOM. We also have the old virtual DOM. React will put these side by side and compare them to figure out what elements in the virtual DOM are modified. In this case, it realizes that our span is modified because that's where we have used the count property. So it will reach out to the real browser DOM and update the corresponding span so it matches the one we have in the virtual DOM. So nowhere else in the DOM is updated, only that span element. Let me show you. So here I'm going to right click on our badge, inspect it. This is what we have in the DOM. Now, every time I click the increment button, you will see that only the span element is updated. So click, see, you can see only the span element is highlighted and nothing else in the DOM is affected. Currently, our handle increment method does not take any parameters. But sometimes in real-world applications, we need to pass arguments with our events. For example, let's imagine here we're dealing with a list of products in a shopping cart. When we click the handle increment button, we want to pass the ID of a product. How can we do this? Well, earlier you learned that in onClick, we need to pass a function reference. So here we cannot call handle increment and pass an argument like 1. We need to pass a function reference. So here's one solution. We can temporarily define another method here. Let's just call it doHandleIncrement for argument's sake. Now, similar to handle increment, we're going to use the arrow function syntax. So we have a function with no parameters. In this function, we can call this.handleIncrement with an argument. Let's say that argument is a product object with the ID 1. Now we can modify handle increment and add a parameter, call it E as in short for event, or product, whatever that parameter is representing. Now we can log this on the console. Okay, and finally, in our render method, instead of referencing this.handleIncrement, we can reference this.doHandleIncrement, right? Back in the browser, when I click the increment button, you can see our product object, which is the argument to the handle increment method. So this was one simple solution, but writing code like this is messy. We don't want to redefine another similar method as a wrapper just to pass an argument to the actual event handler. A better solution is to use an inline function here. So in onClick, instead of referencing this, the doHandleIncrement, we can simply pass this arrow function in between curly braces. So we write code like this. No parameters goes to this.handleIncrement, and then we pass an argument. Now, when rendering a list of products in a shopping cart, in our map method, we have access to a product object. So instead of hard coding this object here, we will pass a reference to the product that we're currently rendering. Okay? With this, we no longer need this helper method. So to recap, whenever you need to pass an argument to your event handlers, simply pass an arrow function here in the body of that function called the event handler and pass an argument. In this section, you learn the essence of React components. More specifically, you learn about JSX or JavaScript XML syntax for describing the UI. You learned about rendering lists, conditional rendering, as well as handling events and updating the state of components. In the next section, we're going to look at composing components to build complex user interfaces. So, I will see you in the next section. In the last section, we worked with single components, but a real-world application consists of a tree of components. So in this section, we're going to look at composing components in React. More specifically, you're going to learn how to pass data between your components. You're going to learn how to raise and handle events, how to have multiple components that are in sync, as well as functional components and lifecycle hooks. These are all very important topics that you will use quite a lot in real-world applications. By the end of this section, you will have a very deep understanding of React components. Are you ready? Now, let's get started. So far in this application, we have worked with a single component. So if you look at index.js, you can see we are rendering a single counter component in the DOM. But as I told you before, a React application is essentially a tree of components. So we can compose components together to build complex user interfaces. And that's what we're going to do in this lecture. So I'm going to add a new component to our application. Here in the components folder, let's add a new file, counters.jsx. In this component, I want to render a list of counters. And then in index.js, instead of rendering a counter component, I want to render a counters component. With this change, our component tree will look like this. Okay, so back in index.js, instead of importing the counter component, let's import counters from the counters module and render that here. Now, back to our new component. On the top, imrc tab, cc tab. Let's call this counters. Okay. Now, in the render method, let's add a div. This is going to be the wrapper or the container for all our counters because we want to return a single element from the render method, right? So here, we want to add multiple counter components. First, on the top, we need to import the counter component from the current folder counter module. Now here, let's render a few counter components, save the changes, back in the browser. You can see we have multiple counter components. Each component has its own state that is completely isolated from the other components. Beautiful. Now let's take this to the next level. Instead of hard coding these counter components here, let's add an array of counter objects to our state property and render them using the map method. So here, let's add a new property, counters. We set it to an array. In this array, we're going to have counter objects like this. Each object should have an ID property, and we're going to use this to uniquely identify each counter. We should also have a value property, and we'll later use this to set the initial value for each counter. For now, I'm going to set this to 0. Now let's duplicate this multiple times and change the IDs. Okay, beautiful. Finally, let's get rid of these counters. Instead, we want to render an expression. Here, this, .state, .counters, .map. We get each counter and map it to a counter component. Also, we should set the key property to counter.id. Save the changes. We still get the same output, and each counter has its own state. Beautiful. However, all our counters are initialized to 0, and the value that we set here is not applied to this counter components. So if I change the value of the first counter to 4, we still get a counter initialized to 0. We'll fix that in the next lecture. In the last lecture, we set the key attribute to counter.id. Using the same syntax, we can set additional attributes here, and with this, we can initialize our counter components. So I'm going to put this on a new line so you can see clearly. Now let's add a couple more attributes here. So I'm going to set value to counter.value, and also selected. I'm going to set this to true. For now, I have hard-coded this value. Potentially in the future, this can be set to a property in our counter objects. Now, back in our counter component, here in the render method, I'm going to temporarily add a console.log and show you this .props. So every React component has a property called props, and this is basically a plain JavaScript object that includes all the attributes that we set in counters component. So these two attributes, value and selected, will be the properties of that props object. Key will not be part of that because this is a special attribute for uniquely identifying elements. So now, let's save the changes and go back to Chrome. You can see we have 4 messages on the console because we have 4 counter components. Look at the first message. Our props is an object with 2 properties, value, which we set to 4, and selected, which we set to true. So now we can read this value and use that to initialize each counter component. So back in our counter component, instead of initializing the count property to 0, I'm going to set it to this .props.value. Save the changes. Back in Chrome, you can see our first counter is initialized to 4. Beautiful. So here in the render method, we no longer need this line. Let's delete that. Also, I would like to rename this count property to value to be consistent with the property that we are setting from the outside. This makes our code cleaner and more maintainable. We don't have to do all the guesswork to remember what name we used where. So put the cursor here, press F2, and rename this to value. We should also rename this count property to value. So it's more meaningful to say a counter has a value as opposed to a counter has a count. Now, one more thing before we finish this lecture. Back in our counters component, here I've set selected to true. If I exclude the value, by default, it will be set to true. Now, going forward, we don't need this attribute, so I'm going to delete it. In the last lecture, you learned that the attributes that we set here are passed to our component using a single JavaScript object called props. Now we have a special prop called children, and we use that when we want to pass something between the opening and closing tag of an element. So here, counter is self-closed, but sometimes we want to pass content in between the opening and closing tags. Maybe we want to pass an h4 here with some kind of title, like this. A real-world example of this is when using dialog boxes. Imagine instead of the counter component, you have a dialog box component, and you want to allow the consumer of that component to pass content to be rendered on the dialog box. So let me show you how to do this. Save the changes. Now, back in our counter component, one more time in the render method, I'm going to show you the props property. So console.log of this.props. Now, back in the browser. So here's our props object. You can see we have the value property just like before, but we have a new property called children. Let's take a closer look. So children is essentially a React element. As we can see here, the type of this React element is h4. So back in our counter component, here in the render method, we can simply render the children prop. So here inside this div, right before our span, I'm going to render this.props.children. As simple as that. Save the changes. Now you can see each counter has a title. We can also make this dynamic. So here in counters component, instead of hard coding this title, we can do something like this: counter number, and then render counter.id dynamically. And here's the result. Now in this particular example, we didn't really have to use the children. We could simply pass the ID as another attribute. We could set that here, counter.id. And in our counter component, we could simply render an h4 that includes this.props.id. We would get the same result. But as I told you earlier, there are times that you want to pass complex elements to a child component, such as a dialog box. In those cases, you use the children prop. Now going forward, we are not going to use the children props, so I'm going to delete the code that I wrote in this lecture. So back in our counters component, let's delete the children. Done. In this lecture, I'm going to introduce you to a very useful tool for debugging React applications. This tool is currently available as an extension for Chrome and Firefox, and as a standalone app for Safari and Internet Explorer. So if you're using Chrome or Firefox, simply search for React Developer Tools. When you install this, you will see a new tab in Chrome Developer Tools. So here in our React application, let's open up Chrome Developer Tools. Here you can see we have a new tab, React. On this panel, you can see the tree of our components. So on the top, we have the counters component. When you expand that, you'll see a div, and below that, you will see all our counter components. Similarly, you can expand each counter component to see its content. So here we have a div with a span and a button. Now, why is this useful? Well, let's go on the top and select the counters component. On the right side, you can see the props and state for this component. So in this component, we don't have any props. So our props is an empty object, but our state has a counters property, which is an array of 4 objects. Let's take a look at the first counter. You can see the key is set to 1. Our props object has 2 properties, ID and value, and our state object has a value property, which is initialized based on props.value. So this panel makes it really easy to visualize what's going on the page, what are various components, what is the state of each component, and so on. We also have this search bar here. So if you're working on a complex page with several components, you don't have to expand them all here. You can simply search for that component in the search bar. Another useful feature here is this $R. So note that as I select each component here, we get this equal $R. What is this? Well, I'm going to select the first one. You know that in the first component, our value prop is 4. Now, if we go to the console tab and type $R, look, we get the instance of our first counter component. So let's expand this. Look at the props. Here we have an object with 2 properties, value, which is 4, and ID, which is 1. So with this $R, we can work with the instance of any components on our page. Let's look at another example. Here I'm going to type $R.render. I'm going to call the render method. You can see we get a React element, which is a plain JavaScript object. The type of this element is div, because here in the render method, we are wrapping the content of our counter with a div. So that's why the type of the React element that is returned from this method is div. Now this $R feature is not limited to React. We have something similar in the Elements tab, but a lot of people are not aware of that. So here in our Elements panel, let's scroll down, expand our root div, expand this again. Here's our first counter, find the button, select that. You can see we've got $0. Similarly, we can go to the console tab, type $0, and this returns that button element in the DOM. We can do something like this, $0.click. We can click the button, and now we can see the count is 5. Let's execute this one more time. Now the count is 6. So have React Dev tools in your toolbox. It makes it really easy to build and debug React applications. So here in the counter component, we're using props to initialize the state. One of the things that confuses beginners to React is what is the difference between props and state. So in this lecture, I'm going to clarify this. Props includes data that we give to a component, whereas state includes data that is local or private to that component. So other components cannot access that state. It's completely internal to that component. In other words, if we go to our counters component, this is where we're using the counter component. All the attributes that we're setting here, these attributes are part of the props, the input to the component. We cannot access the state of this component. The state is local and internal to that component. Similarly, this counters component has its own local state, which is completely invisible to other components. Now, sometimes a component may not have a state. It may get all the data that it needs via props, and you're going to see that later in this section. One more thing you need to know about props versus state is that props is read-only. In other words, we cannot change the input to this component inside of this component. Let me show you. So if we go back to our counter component, here in handle increment, I'm going to change one of the properties of the props object. So this.props.value, I'm going to set that to 0. Let's see what happens when we click the increment button. So here I'm going to click this button. We get this error, cannot assign to read-only property value of object. So React does not allow you to change any properties of the props object. It's purely input to a component, and we should not modify the input. If we need to modify that input during the life cycle of a component, then we need to get that input and put it in the state. In this case, our counter component has its own local state, so we can modify this value in our handle increment button as we have done here. So let's delete this line. Next, we're going to talk about raising and handling events. Now let's take this application to the next level. I want to add a delete button next to each counter. So here in our counter component, in the render method, right after our increment button, I want to add a new button. So a button with a few classes, btn, btn-danger to make it red, btn-sm to make it small, and m-2 to add a bit of margin around this button and the increment button. Now let's type the label, delete, save the changes, back in the browser. Here's our delete button, beautiful. Now let's handle the click event. So here we want to add onClick and set it to a method in this class, like this, that handle delete. However, if you look at the state of this component, you can see in this state object, we only have the value property. But in order to delete a counter, we need to delete it from this array of counters that we have in the counters component. And this brings us to a very important rule of thumb in React applications. The component that owns a piece of the state should be the one modifying it. In this particular example, this piece of the state, that is the list of counters, is part of the counters component. So modifying the state should be done by this component itself. Adding a new counter to this array or removing an existing one should be done inside of this component. Now, in the last lecture, you learned that the state is something private and internal to a component. It's not visible to the outside. So you might be wondering, how can we modify this state from the counter component? Because this is where we have placed our delete button. To solve this problem, we should modify our counter component to raise an event. We're going to call that event onDelete. So our components can raise events, and this is the naming convention we use to name those events. So the counter component will raise this event, and our counters component will handle this event. In other words, we should implement the handle delete method in the counters component, not the counter component. This concept of raising and handling events is something that you see in a lot of libraries for building user interfaces. It's not specific to React. Now let me show you how to implement this concept in React. Basically, we need to add a new method to our counters component and pass a reference to that method via props to the counter component. So here in the counters component, let's add a new method, handle delete. This is our event handler. Here, let's do a simple console.log event handler called. Now we want to pass a reference to this function using props to our child component, that is our counter component. So earlier we passed a couple of props here, value and ID. Now we can pass another prop. We're going to call that prop based on the name of our event. So the name of our event is onDelete. We're going to set this to this.handle delete. So now that we're passing a reference to this function to our child component, let's go to our child component and modify this onClick expression. So instead of referencing this.handle delete, which does not exist in this component, we want to reference this.props.onDelete, because that's the name of our prop, right? Save the changes, back in the browser. Here with the React tab open, let's look at one of our counters, look at the props. Now we have a new prop, onDelete, which is a function. So let's go to the console tab, click this button, we get the message event handler clicked. So in this implementation, our counter component is raising an event and its parent, that is counters component, is handling that event. This is a very common pattern that you see in a lot of real-world applications. And you're going to see several more examples of this throughout the course. But we are not done yet, because in our handle delete method, we're simply doing a console.log. Here we need to update the state, and that's what we're going to do next. To update the state, we need to add a counter ID parameter here, so we know which counter we need to remove from this list. Now, to make sure that all the plumbing is going to work, before updating the state, first, let's just display counter ID on the console. Now we need to go back to our counter component. Here's our delete button. We need to change this expression and pass the ID of this counter. So as you have learned before, we pass an arrow function, and here we call onDelete with this.props.id. Now let's test this. So back in the browser, I'm going to delete the first counter. You can see the ID of that counter is 1. Beautiful. Let's try another one. That is counter with ID 2. Perfect. So now let's go ahead and update the state. Here in the counters component, as I told you before, in React, we do not update the state directly. In other words, we're not going to remove a counter from this array. Instead, we're going to create a new array without a given counter, and then call the setState method of our component and let React update the state. So here I'm going to define a new constant, call it counters. We're going to set this to this.state.counters. Use the filter method to get all the counters except the one with the given ID. So C goes to C.id does not equal counter ID. Now we have a new array. So let's call this.setState. Pass an object. We want to overwrite the counters property with this counters constant. Also, as I told you before, here because the key and value are the same, we can simplify this code like this. Now let's test this. So back in the browser, I'm going to delete the first counter, gone, another one, beautiful. So our implementation is working, but there is a tiny issue here that I would like to improve. If you look at the render method of this component, here we're passing 3 props to our child component. OnDelete, which is a function, as well as value and ID. Now, one question you might have is why do we have to pass ID and key while their values are exactly the same? This looks like unnecessary repetition. The reason for this is because this key attribute is used internally by React. So we won't be able to access it in our counter component. That's why we have to pass ID as a prop and then read it via this.props.id. Now, the tiny issue we have here is that we have passed value and ID as separate props. Both these are properties of the counter object. If in the future we add a new property to our counter object, we'll have to come back here and set a new prop, like selected. We set it to counter.selected. And over time, this is going to get messy and ugly. The whole point of using objects is to encapsulate related values. So instead of these 3 properties, we could simply pass the counter object itself. This object includes everything we need to know about a counter. And also, if in the future we add a new property to this counter object, we don't have to come back here and modify this code. Our counter object is carrying all the data about a counter. So with this change, now we need to go back to our counter component and make a couple more changes. Here on line 23, this is where we have our delete button. We need to change this expression. We no longer have the ID property in our props object. So we need to prefix this with counter. Similarly, on the top, where we initialize our state, again, we don't have the value property. We need to prefix it with counter. Save the changes. Let's test the application. So we can increment each counter, beautiful, and delete them. Perfect. We have an issue in our current implementation, and that is that we don't have a single source of truth. Let me show you this using an example. So here on the top, I want to add a button for resetting all the counters. So let's go back to our counters component. Here in the render method, on top of all these counters, let's add a button with a few classes: btn, btn-primary, btn-small, and margin2. And we're going to call this reset. Now, let's handle the click event. We're going to set this to this.handle reset, just like before. Nothing new so far. And here I'm going to implement handle reset. We set it to an arrow function. And in this method, just like our handle delete method, we want to create a new array of counters and call this.setState. So we get the existing counters, this.state.counters. We use the map method to get each counter and reset its value to 0 and then return it. So with this, we'll get a new array of counters. Let's store them here and then call this.setState with this new array. So save the changes back in the browser. Let's click the reset button. Look, nothing is happening here. Why is that? The reason is because we don't have a single source of truth. Let me show you what I mean. So I'm going to open up the Chrome Developer Tools. Let's go to the React tab. So here's our counters component. Look at the state for this component. We have an array of 4 counter objects. If you look at one of these counters, you can see its value is 0. So we successfully updated the state, but we are not seeing the changes in the DOM. Let's take a look at one of our counters. So expand this. Here's our first counter. Look at its props. We have this counter object that we passed from its parent. Look, the value is 0, but we don't see that on the view. Instead, we see 4. So the issue we're facing here is that we don't have a single source of truth. Each of our components have their own local state. Our counters component has an array of counters, and each counter component has a value. This value is currently disconnected from the value property of each counter object that we have in this array. Here's the implementation of our counter component. As you can see here, we're initializing the value property of our state object based on what we get from our props. This piece of code is executed only once when an instance of a counter component is created. So that's why when the page loads, we get the initial value here, and we can increment it because this is a local state in our counter component. But when we click the reset button, the local state of this counter component is not updated. So how can we fix this problem? We need to remove the local state in our counter component and have a single source of truth. And that's the topic for the next lecture. So here in the counter component, we want to remove the local state and only rely on the props to receive the data that this component needs. We refer to this kind of component as a controlled component. A controlled component doesn't have its own local state. It receives all the data via props and raises events whenever data needs to be changed. So this component is entirely controlled by its parent. So let's go ahead and do this refactoring. First, we're going to delete the state property. Next, we need to find any references to this.state and update them accordingly. The first reference is in our handle increment method. So since we no longer have the local state, it doesn't make sense to have this method here because this counter component is going to be a controlled component. So whenever the data needs to be modified, this component needs to raise an event and have its parent take care of modifying the data. So delete. Here's our increment button. Instead of referencing the handle increment method, which no longer exists, by calling a method in the props object, just like how we raised the onDelete event here. So let's get rid of this expression. We're going to pass an arrow function, and in the body of this function, we're going to call this.props.onIncrement. So that's the name of our event. Now, as an argument, we need to pass either the counter ID or a reference to this counter object. I'm going to pass a reference to the counter object because this will make the implementation of our event handler simpler, as you will see in a few seconds. So this.props.counter. We pass the entire counter object and let the event handler take care of incrementing the value of this counter. Now, let's find any more references to this.state. So we have two more references here that need to be modified. One is in getBatch classes. So here we need the value of the counter. We can read that from this.props.counter. Here's the last reference. So here we're using object destructuring to read the value property of the state. Since the state property is gone, we're going to read the value from this.props.counter. So we're done with the removing of the local state of the counter component. Here we no longer have a state property, and we're relying entirely on the props object to display data and notify changes. Now let's go back to our counters component. We need to add a new event handler, handle increment. We set this to a function that takes a counter parameter. For now, let's just do a console.log of counter to make sure all the plumbing is working before we move on to update the state. Next, we need to go to our render method. So earlier we handled the onDelete event. Now we handle onIncrement, and we set this to this.handleIncrement. Let's test the application up to this point. So save and back in the browser. I'm going to increment our first counter. So we get that counter object here with the value 4. Beautiful. Now we need to update the state. Just like before, we are not going to update the state directly. Instead, we should create a new counters array and give it to the setState method and have React update the state. So let's create a new constant, call it counters. We set it to a new array. And here I'm going to use the spread operator to clone this.state.counters. So we're cloning this array. With this, we'll get a new array of counters. However, the objects in this new array are exactly the same objects that we have in the counters array that we have in the state object. Let me show you. So if we go to our new counters array, get the first counter and increment its value, this is going to directly modify the value property of this counter object that we have in the state. So let's do a console.log of this.state.counters of 0. Save the changes back in the browser. I'm going to increment our first counter. Now we can see its value is 5. So we have modified the state directly. And this is a no-no in React. To solve this problem, we need to clone the counter at the given location. So we'll have a different object than the one in the state. We don't have to clone the other counter objects here because we're not going to modify them. So we set counters of 0 to a new object. And once again, we use the spread operator to clone this counter object that we receive as an argument here. Let's test the application one more time. Back in the browser. Now, if I increment the first counter, you can see the value is not updated. So the counter object that we have in the state remains unchanged. Now here we are working with the first counter in this array. Instead, we need to find the index of the counter that we receive as a parameter. So let's define a new constant, index, and we set it to counters.indexOf. We pass our counter object, and finally we replace all these zeros with index. And the last piece is to update the state. So we call this.setState and give it this new counters array. Let's test the application. Back in the browser, I'm going to increment the first counter. Beautiful. Let's delete some of these and click the reset. Perfect. Now let's take this application to the next level. I want to add a navigation bar here on the top, and there I want to display the total number of counters on this page. You have seen this pattern before. It's similar to displaying the total number of products in a shopping cart. So as we add products to our shopping cart, we can see the total number gets updated on the navigation bar. So let's go ahead and implement this pattern. Back in VS Code, let's go to index.js. You can see our root component is the counters component. So here's a visualization of our component tree. We have the counters component on the top, and below that we have the counter component. Now we need to change this structure to something like this. So we want to have the app component on the top. Below that, we want to have a navigation bar and our counters component. So back in index.js, on the top, I'm going to bring back the app component and replace this counters component with app component. Now let's go to app component. So app.js. What we have here in the render method is the default black banner that comes with React projects. We want to replace this with a basic Bootstrap template. I showed you how to do this in the last section when we set up the Vidly project. But let me quickly refresh your memory. So we go to getbootstrap.com. Under examples, if you scroll down, you can see various templates. I'm going to pick a very simple starter template. So we want to have a page like this. Now right click here, go to view page source. Under body, you can see we have a navigation bar, and next to the navigation bar, we have this main element with the class container. This is the container for the content area of our application. Now, we don't want a complex navigation bar like this. So let's go back here, go to documentation, and search for nav bar. On this page, if you scroll down, you can see a very simple navigation bar under brand. So this is the layout that I'm looking for. I don't want any links or drop-down lists here, just a simple navigation bar. So here's the markup. I'm going to copy this. Now, back in VS Code, we should create a new component for our navigation bar. So a new file. Let's save this under the components folder and call it navbar.jsx. Now, just like before, imrc on the top, and then cc navbar. Here in the render method, we simply return the markup that we copied from Bootstrap. We just need to rename class to class name, and we're done. Also, we don't need the state here, so let's delete it. So here's our navigation bar component. Now, let's go back to app.js. We don't need this markup anymore. Instead, we want to render our navigation bar. So on the top, we also don't need the logo. Let's import navbar from the components folder /navbar. And then here, we add our navbar component. Now below that, we should add our main element with the class container. And inside this element, we're going to add our counters. I'm going to go back to index.js. On the top, you can see the line for importing the counters is grayed out because we are not using the counters component here. So let's cut this from here and paste it in app.js. And finally, let's add the counters element inside the main element. Now you can see here we have a compilation error because of this red underline, because we're returning multiple root elements from the render method. So we need to wrap them with a react.fragment. So react.fragment, and then we close it here. Okay, beautiful. Back in the browser. So here's our new layout. We have the navigation bar on the top, and below that we have our counters. Now, we want to display the number of counters on the navigation bar. Here's our component tree one more time. Earlier, we passed the state of the counters component to the counter component via props. This is because we have a parent-child relationship between these two components. But as you can see, there is no parent-child relationship between the counters component and the navbar component. So how can we display the total number of counters on our navigation bar? Well, in situations like that, when there is no parent-child relationship between two components and you want to keep them in sync, you want to share data between them, you need to lift the state up. So in this case, we want to lift the state of the counters component to its parent, that is our app component. Now, both the counters and navbar components have the same parent. This is where we have the state, so we can pass it to all the children using props. And that's what we're going to do next. So here in counters component, this is where we have the state, the list of counters, as well as the methods that modify or mutate the state, such as handle increment, handle reset, and handle delete. We should move the state as well as all the methods that modify the state from this component to its parent, that is app component. So I'm going to select all this code here, cut it, go back to app component, and paste it right here. That was the first step. Now, back in counters component, here we have a reference to this that handle reset. But this method no longer exists in this class. Now it's part of its parent. So we need to pass it down using props. So back in app component, let's look at the render method. This is where we have our counters component. We want to modify this to raise events such as on reset, on delete, and on increment. So on reset, we set this to this that handle reset. On increment, we set this to this that handle increment. And on delete, which we set to this that handle delete. So these are the three events that are raised by this component, and here are the corresponding handlers that belong to the app component. Now let's go back to counters component. So we should change this expression to this that props that on reset, because that's the name of the property that we set on the prop object. So one more time, in app component, these are the properties of the prop object, right? Now, one more time, back in counters component, we should also update the reference to handle delete and handle increment. So one more time, this dot props dot on delete and this dot props dot on increment. Basically, what is happening here is that this counter component raises the delete event, and here we're bubbling that event to our parent. So we're not handling that event in this component, we're simply bubbling it up to the parent of this component. And one last change we need to make here, since we no longer have the state in this component, we need to pass the list of counters via props. So we should change this to this dot props dot counters, and also back in app component, we should pass the list of counters right here. We set this to this dot state dot counters. So now this counters component is a controlled component because it doesn't have any state. It simply receives data and methods to modify the data via props. So it's entirely controlled by its parent. So this is how we lift the state. Now let's test the application and make sure everything is working. So let's increment a couple of these, then reset them, delete a couple of them. Beautiful. Finally, we need to display the total number of counters here on the navigation bar. So here in app component, we're passing our counters to our counters component. Similarly, we can pass this array to our navigation bar component. So we can pass either the counters array or just the total number of counters. So the nav bar itself doesn't have to do the calculations. We can simply give it a number. So total counters, we set it to this, dot state, dot counters, dot length. Or we could take this to the next level and filter only the counters with value greater than 0. So we get counters, filter them where counter.value is greater than 0, and then we'll get the total number of those counters. So save the changes. Now let's go to navbar component. This is where we have the label. Right after that, I want to add a span with a few classes like badge, badge-pill, and badge-secondary. Here we render this .props.total counters like this. Save the changes and back into browser. So currently we have only one counter with value greater than 0. Let's increment the second counter. Now the value is updated to 2. If we delete the first counter, the total number of counters is updated accordingly. So we lifted up the state from the counters component to its parent, which is the app component. Now we can share this state with the children of this component via props. And with this technique, we have multiple components in sync. So if you look at our navbar component, we only have a single method here. That's the render method. We don't have any event handlers here. We don't have any helper methods to calculate values. We only have a single render method. Also, we don't have any state. We're getting all the data via props. In situations like this, we can convert this component into what we call a stateless functional component. So instead of using a class to define this component, we can use a function. Let me show you how to do this. So we define a constant, call it navbar, and set it to an arrow function like this. In the body of this arrow function, we return a React element. So basically, we take our return statement from here and move it inside of this function. So instead of having a class that extends the component class with a render method, we simply define a function that returns a React element. That's why we call this a stateless functional component. Now, there is nothing wrong with using classes to define components, but some developers prefer to use functions when they're dealing with simple stateless components. What approach you choose is purely your personal preference, but you see a lot of examples of stateless functional components on the internet. That's why I decided to include this in the course. Now, we also have a shortcut for creating these stateless functional components, just like we have CC for creating a class component. We have SFC for creating a stateless functional component. So this gives us a template for defining a function and also exporting it. Now, we don't need this, so delete. Now, one more thing before we finish this. Here we're referencing this .props. This only works in class components. In functional components, you need to add props as a parameter here, and then remove this. React will pass the props object as an argument to this function at runtime. Here in our navbar component, we have a single reference to the props object. Sometimes when working with a more complex markup, we might have multiple references to the props. We don't want to repeat props dot several times. So we can use object destructuring to destructure this props argument. In this particular example, we are interested in the total counters property of this object. So we can destructure this argument and pick the total counters property. First, we add parentheses, then we use curly braces for object destructuring, and then pick the properties we're interested in, like total counters. With this, we can remove props dot, and this simplifies our code. Similarly, if you look at the counters component, you can see here we have several references to this.props. We can simplify this code by using object destructuring. So here in the render method, just before the return statement, I'm going to define a constant, use object destructuring to pick the properties of the props object we're interested in. The first one is onReset, so we pick that. The second one is counters. Let's add that here. We also need onDelete and onIncrement. So onDelete and onIncrement, we pick all of these from this.props. Now, anywhere we have this.props dot, we can replace all of those with nothing. And this makes our code cleaner. Our components go through a few phases during their life cycle. The first phase is the mounting phase, and this is when an instance of a component is created and inserted into the DOM. There are a few special methods that we can add to our components, and React will automatically call these methods. We refer to these methods as lifecycle hooks. So they allow us to hook into certain moments during the life cycle of a component and do something. In the mounting phase, we have 3 lifecycle hooks: constructor, render, and component did mount. React will call these methods in order. The second lifecycle phase is the update phase, and this happens when the state or the props of a component get changed. In this phase, we have 2 lifecycle hooks, render and component did update. So whenever we change the state of a component or give it new props, these 2 methods are called in order. And the last phase is the unmounting phase, and this is when a component is removed from the DOM, such as when we delete a counter. These lifecycle hooks you see here are the frequently used ones. If you look at the React documentation, you will see a few more lifecycle hooks, but they are rarely used, and that's why I didn't want to confuse you with too much details that you're not going to use that often. 90% of the time, you're going to use only the lifecycle hooks that I've listed here. Now, let's see these lifecycle hooks in action. So here in the app class, first, let's look at the mounting phase. I'm going to add a constructor. And because we have added a constructor here, we need to call the constructor of the parent class using super. So here we have a constructor. Let's do a simple console.log app constructor. This constructor, as you have learned before, is called only once when an instance of a class is created. This is a great opportunity for initializing the properties in that instance. For example, one common use case is to set the state based on the props that we receive from the outside. For example, we can set this.state to this.props.something. So here in the constructor, we set the state directly. We don't call this.setState. In fact, if we do that, we will get an error because this method can only be called when a component is rendered and placed in the DOM. So if you need to set the state directly, you can do so in constructor. Also note that here, we won't have access to this.props unless we pass props as a parameter to this constructor and also pass it to the constructor of the base class. Otherwise, this.props will return undefined. Let me show you. So temporarily, I'm going to comment out this line and log this.props here. Here in the console, you can see our constructor is called and our props object is an empty object. But if you forget to add the props to this constructor, we won't be able to access it. So to recap, the constructor is called once and it's the right place to initialize the properties in this class. Now let's remove this.props from here. The second lifecycle hooks we're going to look at is component did mount. Component did mount. This method is called after our component is rendered into the DOM, and it's the perfect place to make AJAX calls to get data from the server. So we can do an AJAX call and then call the set state with new data. For example, in our video application, later in the future, we're going to get the list of movies from the server and then pass that list to our set state method, something like this. For now, we don't have to worry about this. Let's do a simple console.log app mounted. And the third lifecycle hook in the mounting phase we're going to look at is the render method, which we have seen before. Let's just add a console.log app rendered. Now, back in the console, look at the order in which these methods are called. First, we have the constructor, then the component is rendered, which basically returns a React element that represents our virtual DOM. Now React gets that virtual DOM and render it in the actual browser DOM. And then our component is mounted. So when a component is mounted, that means that component is in the DOM. And once again, this is the right place to make AJAX calls and get the data from the server. Now, one thing you need to know about the rendered method is that when a component is rendered, all its children are also rendered recursively. Let me show you. So here in our app component, look at our render method. Here we have a navbar and a counters component. So let's go to our navbar component. Here we have a stateless functional component. In the body of this function, before our return statement, let's do a console.log and display navbar rendered. Now, one thing you need to notice here is that you cannot use lifecycle hooks in stateless functional components, because here we have a single function that returns the output of this component. So if you need to use lifecycle hooks, you can only use class components. Now, let's go to our counters component. Once again, here in the render method, I want to add a console.log with a message like counters rendered. And the last part, let's go to our counter component, do the same here in the render method, and change the message to counter rendered. Now let's go back to the console. As you can see, first the constructor of our app component is called, and then our app component and all its children are rendered recursively. So we have app, navbar, counters, and 4 instances of the counter component. And finally, at this point, our app is mounted and is in the DOM. So this is our mounting phase. Now let's look at the update phase. So that phase happens whenever the state or props of a component changes. As an example, let's look at our increment button. So let's go back to our app component. Here's our handle increment event handler. In this method, we're updating the state of app component. So this will schedule a call to the render method. So our app is going to be rendered, which means all its children are going to be rendered as well. Let's see this in action. So back in the console, I'm going to clear the console and click the increment button. So once again, you can see our entire component tree is rendered. Now I just need to clarify that when I say our entire component tree is rendered, that doesn't mean that the entire DOM is updated. When a component is rendered, we basically get a React element. So that is updating our virtual DOM. React will then look at the virtual DOM. It also has a copy of the old virtual DOM. That's why we should not update the state directly, so we can have 2 different object references in memory. We have the old virtual DOM as well as the new virtual DOM. Then React will figure out what is changed, and based on that, it will update the real DOM accordingly. So here, even though we have several counters, when I click the increment button, only this span is updated. Nothing else will be affected. Let me show you. So if I go to the Elements tab and select this element here, I'm going to click the increment button and I want you to look at the span here. So increment, see it gets highlighted because its content is updated. However, if I select another counter and click the increment button of the first counter, look, nothing is happening here. So there is no update on this part of the DOM. Now back in our counter component, I'm going to add another lifecycle hook here. Component did update. This method is called after a component is updated, which means we have new state or new props. So we can compare this new state with the old state or the new props with the old props. And if there is a change, we can make an AJAX request to get new data from the server. If there are no changes, perhaps we don't want to make an additional AJAX request. This is an optimization technique. So let me show you. Here we add a couple parameters, previous props and previous state. Let's do a console.log of previous props, as well as another console.log to show the previous state. Now save the changes back in the console. I'm going to clear the console and click the increment button of the first counter. Note that the value is currently 4. So click, look at the console. So ignore all the rendered messages. Look at the first previous props. So this is the props object that we're passing to this counter component. You can see the value of the counter was previously 4, but now it's 5. So we can write code like this. If previous props.counter.value is different from this.props.counter.value, then perhaps we're going to do an AJAX call and get new data from the server. However, if the value is not changed, perhaps we don't want to make an additional call to the server. Of course, this does not make sense in the context of our counter example, but what I want you to take away here is that with this method, component did update, we can decide whether we should make an AJAX call to get new data based on the changes in props and state objects. Now finally, let's look at the unmount phase. So in this phase, we have one lifecycle hook that is component will unmount. So this method is called just before a component is removed from the DOM. Let's do a console.log of counter unmount. Now back in the browser, I'm going to clear the console again. Now note that when I delete this first counter, we will see the unmount message on the console. See what's going on here. As a result of deleting a counter, the state of app component is changed. So our entire component tree is re-rendered. We have app, navbar, counters, as well as 3 counter components. So with this, we have a new virtual DOM that has one less counter. React will compare this virtual DOM with the old one. It figures out that one of our counters is removed. So then it will call component will unmount before removing this counter from the DOM. And this gives us an opportunity to do any kind of cleanup. So if we have set up timers or listeners, we can clean those up before this component is removed from the DOM. Otherwise, we'll end up with memory leaks. In this section, you learned a lot about composing components. More specifically, you learned how to use props to pass data to your components, as well as raise and handle events. You learned about lifting the state, and with this technique, we could have multiple components that shared the same data and were in sync. You also learned about functional components and lifecycle hooks. In the next section, we're going to extend our Vidly application and add pagination, sorting, and searching. So I will see you in the next section. You made it this far, and you seem to be very enthusiastic about learning React. I hope you have learned a lot in this crash course, so please support me by liking this video and sharing it with others. If you want to learn more from me, I've got a comprehensive React course that's the continuation of this crash course. In that course, we'll talk about pagination, searching, sorting, calling backend services, authentication and authorization, deployment, and more. As I told you before, the link to my course is in the video description. Thank you so much and have a great day.